Welcome to the July meeting. I just wanted to go through quickly the organizers again. It's Martin in Perth, Dan in Brisbane, Renee's in Fiji at the moment, so he's not connecting in because he couldn't get internet connection. Wagner from Auckland and myself from Melbourne, and Dan said he was running late on public transport, so everybody's having fun tonight. And tonight we have Mick Badran, CTO and founder of Handled. He's going to talk about modeling and integrating with Azure machine learning. So at this point, let me change presenter to Mick and we can get started. Okay, Mick. So I've changed presentation to you, Mick, and you just need to share your screen.
Okay. Let me just. All right, how's that gone?
That's good. I can see your screen.
Wonderful. I'll just clear it up a little bit.
I'll monitor the questions while you're doing that, and then we can just make if people have questions, I'll bring those up to you.
Okay, no problem. So I'll just go into presentation mode on PowerPoint here. Hopefully that comes across okay.
Yep, that looks fine.
Great. All right. Look, welcome guys, and thanks very much for making your time available. So I thought what I'd do is share a little bit around some of the modeling and integration with Azure machine learning that I've done over the last year and a half, and just kind of give you potentially a different slant or insight into how you might incorporate these sorts of services in your application. Okay, so as Bill mentioned, I left a corporate job and went away and co-founded a company called Handled that helps Aussies pay less for energy. So solving a real problem, and this is just the tip of the iceberg. So in terms of, when we start to talk about modeling, we can get lost pretty quickly in semantics, and the model really doesn't make sense to us, and it tends to lose its relevancy down the track. My question's always around, how did you decide on that model? What were the inputs that you used, and what's the output? So how do you know that this thing is actually successful? Apart from maybe you read about it in a book, or you got someone else's model and plug numbers into it. So it became a function that you could call with X, Y, Z, and you got a result of something out, but you didn't, we don't really understand what went on. So what I want to do is kind of take you through our journey and take you through my journey and where we got to. So simply put, if you can just have a simple model with a lot of data, then it's going to be fantastic. Great place to start than these more complex models that potentially take longer to run, harder to figure out and work with. And, obviously data is your key here. So you want to be able to have more data to discuss trends and things like this on. One of my favorite quotes is the cloud, and back in the day, 640K ought to be enough for anybody. And here we are living in the cloud with most of your mobile phones and devices having hundreds of thousands of more compute power than the computers back in those days. Maybe I'm showing my age a little bit there. Okay, so just quickly, this is who I am. You can contact me on those details there. And just to give you a quick bit of background, these are the people that keep me sane in my life, my other half. Honourable child number 1 with his grandma, having fun, getting up to no good. That's honourable child number 2, and between them I'm their tech support at home. And this is Honey, my golden retriever, is the only person that listens to me. So, okay, onward and forward. So I just wanted to talk to you a little bit around, why did we start on Handled, and what was the driving force behind that? And really, if you're familiar with the energy market, you'll be aware of just how much we don't know. you end up getting your electricity or your gas bill, and there's a big box there that says pay $300, pay $400, whatever the amount is, and that's the easiest thing to figure out. So we all go ahead and pay it. And then each time we get a bill, we go, gee, you know, electricity's up, maybe I'll turn the light off, or maybe I'll run the dishwasher less or something. But you don't really know whether you're on a good deal, whether you're on the right plan, or whether there's any better plans out there in the market for you. And this is really just the starting point, or the tip of the iceberg for us. So, you know, certainly the energy market is prevalent with a mismatch, if you like. So we wanted to turn around and basically help people optimize their circumstance and also look after their privacy. So today we're looking at energy in the form of electricity and gas, solar and battery storage. So being able to take control back of those things and saying, well, I'm going to, you know, what can I do to optimize my energy consumption? How can I reduce my bill? And look, in our journey of you know, a year and a half, we looked at a whole raft of different things, from plugging various devices into meter boxes called home energy monitors, and just working out exactly how much you used, when and where. And predominantly we found that you know, if you turn the lights off, or if you ran the washing machine or the dryer a little bit less, they were saving you dollars and cents, you know, pretty much. The simplest, easiest thing to do is to work out whether you're on the best plan or deal in the market by the providers, like by the retailers. So by doing that, on average, we've found that we save our members $500 a year, just simply. Some, you know, some are a little bit less, some are a lot more, up into $2,500, $3,000 a year, which is just incredible to be able to, you know, save that. And obviously the next things that people say to us is, can you look after my internet? Can you look after my mobile phone? You know, so there's all these other spin-offs of being able to optimize, you know, doing tasks for people that they're too busy to do, or, you know, giving them the convenience of being able to do it. And all this is free, by the way. So, you know, it's important that we show the whole market so that we can all make an informed decision around it, and come up with a, you know, an awareness of just exactly where we do sit and what other deals and offers are available around us. So certainly just the beginning. You know, there's a whole raft of things that we want to do, and this is just the starting point for us. So in terms of what I want to talk about tonight, is basically just want to give you some context. So just have a quick sort of walkthrough of what we're talking about with handled, getting your electricity handled, getting your gas handled, getting your energy handled, etc. At the moment, this has come through as an app in both the App Store and Play Store, and written in Xamarin Forms, cross-platform, etc. We're all totally 100% in the cloud, mobile first, cloud first, using a cliched phrase. And to give you some real world context around, you know, if I start to talk about a model and what we'd like to do, it's hard to sort of make the jump between how's this going to affect me, my day-to-day life. So a lot of the models I've seen are around, you know, trying to predict criminal behavior, trying to do some gene modeling on disease genes in you know, potential cancer research and things like this. And it's very easy to feel disconnected from that in our day-to-day world of what, you know, we're doing. So I wanted to give you some context around you know, the model. One of the models we use quite a few, but I've picked one of the ones that's nice and visible for us. And then we all know about machine learning, or maybe we don't, but, you know, it's a great buzzword, and it was a fantastic buzzword, you know, a little while ago. It's now turned into AI, we all like to have, you know, deal with AI and have AI in our systems and have smart this and smart that. I'm just waiting for the whole Terminator and, you know, Skynet to come along, because that's coming up next, you know, the AI bots and everything else. And just talk a little bit about some of the integration that we settled on, that I settled on, and it's a little bit, you know, potentially unorthodox or a little bit different to maybe the classic sort of walkthroughs and material that you get out there on the web. And just to talk to you how we came about that, how that we arrived at that, and obviously demo the modeling and demo the machine learning aspects of it. So let's get started. And this is my special link, by the way, this one. So you can go and grab the app and get it from my special link, and that way we're having a competition internally as to who can get the most installs of the app, and that's mine. You'll jump me up on the leaderboard if you go and grab the app from there, and just go and install it. So when we're talking about developing systems and integration, there's a, you know, one of the things that we tend to live by is rather than ask the question of why should we use that technology or that service, why not should we use that technology or service? So my general sort of thoughts here are, the less code that we have to write means less risk, less bugs, and less support for us and faster time to market. So what I'm going to do is to just see if I can get to, there we are. So this is, I'm just mirroring my my phone at the moment, and maybe later. Can you guys see that?
Yes.
Yeah,
we
we
can,
can see it.
Okay, cool. Sometimes these things, yeah, be a little bit funny. But all right, so here's the app handled. Oh no, I won't click on it on the screen. I'll click it on the phone, and up it pops. So the first thing that basically you do is to say, tell us a little bit about yourself, and we can then start to predict some of get these numbers into the system and start getting the app to work for you. So I'm just going to show you just on the left-hand side. So these are some test households that I've got, and basically they cover New South Wales and Southeast Queensland just for now. We are expanding out shortly, but we needed to launch with something that we could realistically attain. So I've selected a house. So as an individual, I can have multiple houses, and here you can see I've got gas and electricity, and to be provided with that information here at the top, I had to supply some, in this case, some bills. So by the way, the new version of the app, the UI is changing slightly. So you know, it's always the way, new and improved. So basically, we've got some details in here about the bill, and that you send through the bill. There is some OCR on the bill, once again, some machine learning, etc. But we just end up getting so many variations of that particular function that there is a manual step. There's a small manual step inside there, and I can turn around once I've got, you know, some information. I can start to turn around and say, you know what, I've actually got 4 people in this house. No, I don't have air conditioning, and my battery storage is off, and then I use gas for my oven. So now this is going to change some of these numbers that we saw a moment ago, and I'll just hit save and continue, and yep, so this is going to change those numbers. Changed it slightly, we didn't really see too much. So that's kind of that side of it just in there. So I'm just going to come back. So once we get your build, and obviously you can see these numbers here that are annually. So we've got per year, you know, an estimated cost per year. And that's ultimately what we want to work with. So this is where what I want to talk to you tonight about is, well, how can we predict this energy usage across the different seasons for the whole entire year when you might have given me only a few days or 30 days or 90 days worth of your actual usage? So why is this particularly important to us, how much you use? And when I say us, I mean the household, our members, because this is actually called the load profile. And if I can figure out how much I'm going to use over a year reasonably accurately, then that opens up the door for a lot of other discussions. So I'd like to go and get solar. I'd like to get some solar panels on my roof. How big should the system be? And, you know, what size should it be? So these are some of the things that I can answer if we have a load profile. So, you know, normally these days when you ask solar on the roof, they'll an installer will come along, they'll look at your roof space and they'll say, your roof space is this much, this big, I can fit 18 panels up there, that's the system you're going to get and pay this amount. So here we can actually optimize the system based on actually how much you use. So maybe you don't need 18 panels, you might need 6 with, you know, potentially the view to grow if you need to, if extra members come into the house, or, you know, you get a pool or something changes. But yeah, it's important to optimize that experience so that you don't over or underspend, because nothing is worse than getting solar and still having to be heavily reliant upon the grid. So this is, you know, this is all really important, and obviously this extends to things like battery storage and other areas. But for today, you know, in terms of our launch, in terms of where we are, we've just got, you know, looking at getting you on the best deal in the market, paying less for energy, and then obviously solar and storage and various other things are going to be coming along down the track. So I can tap on, you know, see how you did, and then we go back to, you know, editing and sorting out these benchmark details. And I'll just see if I can, I'm going to drop back to 2 people, and I'll just save that for the moment and jump over to the dashboard. If I can get there before it changes. We saw some change there, and these graphs changed slightly, these dials changed slightly. So at this point in time, I can, you know, this is potentially, some people love this area, this space, they can see what's going on, they can benchmark, they can see where, you know, how they compare against other people. Once I've got all this information, I can now come along and say, well, show me what's in the market. So show me the various deals that are in the market, and these little icons indicate various preferences that I might want to have around, you know, I'd like to have only fixed rates or no exit fees, or you'll actually be surprised at the amount of, you know, the types of practices that go on in this industry. You'll be horrified. I certainly was. So we've got a whole list here, and then essentially we can tap on one, have a look at it and say, you know what, I'd like to go and switch to it. And depending on who it is, we can do that in the application itself. So it shows me a little bit about it. I can jump out and say, well, what's the, you know, what's some of the fact sheets and things like that. So I get, you know, some bona fide legal information around what's going on. And the worst thing here is that you can see that I can save potentially $379 in this particular household in this deal if I chose the first one, which is fantastic, right? I'm able to go and do it very easily in the app. I can also set an alert just here that says, well, you know, let me know when I can save $300, because that'd be awesome. And rather than me having to come and look in here again, and my mobile phone company, for where this came about was my mobile phone company, for example, does that exact thing. I ring them up very seldomly, and essentially they say, you know, I've got a problem, I can't do X, Y, Z. And they say, let me bring up your account. What plan are you on? I go, I'm on the $70 a month plan. And usually the response is, oh, we haven't had that plan for a year or so. We've now got a $40 a month plan that can give you twice as much. And, you know, obviously you sit there and go, well, where was the phone call? Why didn't someone let me know? Because that would have been awesome. Now, the thing just to remember here in terms of these retailers or providers, as they're called, they absolutely don't do anything to your electricity. So your electricity on how it arrives into your house is through poles and wires out the front. And those poles and wires are handled by a distributor in, for example, in my area in Sydney, it's a company called Ausgrid. Now there's Energex and there's Endeavour and there's a variety, there's 5 in Australia. So those guys look after the distribution of electricity, and the generation comes from exactly the same place. So a lot of the questions that, you know, our members kind of come up with is to say, ask us is to say, well, you know, if I change to another provider here, will I get blackouts? And all these people do is look after the bill, look after where my bill comes from. So just to give you a little bit of an idea as to, you know, the environment and the market that we live in, if you like. Okay, so I'll just jump back to the dashboard, have a look at these dials, because that's what I want to focus in on at this point in time. Wonderful. So hopefully, you know, look, feel free to grab the app, download it and install it. Use this link, by the way, use that link, and we'll see how we go. All right, so the real world context, it's all about the data set that we have and this load profile. So without going and sticking something at your house or getting access to that smart meter, which we're looking into for phase 2 and things like this, you know, the bill is probably the best, and it gets us maybe 85 to 90% there, which is great. And you know, just some of the other things around, well, what affects this load profile? So, you know, if you start to think of a model, start to think of, we're predicting this seasonal yearly usage, and what are some of the things that we think are going to affect it? So there's things like location. So whereabouts you live in Australia would obviously affect it. Warmer regions, colder regions, and things like Bureau of Statistics. They also have, you know, various indicators and weighting factors, not so much on how much energy you use, but how livable each postcode is. They've got a livable index, which we also incorporate into giving us some of these seasonal factors, seasonal weightings that we use. Okay, so let's move on to making all this work. So we start to look at modeling, okay, and our machine learning integration, ML integration. So the first thing that we'd like to do is to pick a model. And so how do you know which model to pick? And how do you know whether it's going to be the right model? So fortunately, there is a cheat sheet, and I've got, where's the link? There we go. I've got a link there for you, and you've got your cheat sheet that essentially walks you through the reasons why you would use one of these models over another. Generally, by the way, well, let me just pause for a moment. Generally, with a lot of these models, you know, you're talking about things like classification models, which is it an A or a B or a C? Which bucket does it fall within? And you know, things like anomaly detection. Out of a whole run of things, is there something that sticks out that shouldn't be there? So that then, in our case, we wanted to come up with given some usage data, given where you are, and some other parameters, what would your usage be across 4 seasons for the year? So we wanted to look at things like some regression testing, and those sorts of models. Obviously, this is just a guide. You don't need to follow this, but it's really a way, if you haven't started out, it's really a way to just make those initial inroads and those initial steps and start going. Is your model good? Don't know. Is it working for you? It depends on what your error parameters are. So generally, a lot of the way that this model works, that the modeling works, is you've got you've got a sample set of data, you train it, and after the training, your model, imagine that there's weights and various other parameters inside the model, internal to it, that are sufficiently set so that when you train the model, you've got the inputs and you've also got the desired outputs. So that's how we train it. We know what the answer is given the inputs. And the beauty about working with these models is knowing how much and how long to train it for. If you overtrain the model, generally, if you overtrain the model, it's only good at the sample set of data. If you get some data that's not in the sample set, it'll go, I don't know what's going on. If you undertrain the model, you won't get an accurate enough result with new data that it hasn't seen. So you've kind of got to pick and choose the right length and to train it for. And there actually is no, magic number on that. It's really sitting down and crunching it out. So this is why start off with a simple model. Start off with very simple stuff and saying, right, well, from here, we run it through, we predict it, and, you can always build on it. Don't try and build your own. Don't try and have it predict all things to everyone, because at the end of the day, it's kind of a closed loop function that you're running. So I'll show you what we've done. So in terms of how some of these factors, so things like how much do you use? Everyone's different circumstances, different households. People have pools, some people don't, et cetera, number of people, dogs, pets. Location we found to be another factor, and then some other factors like pool, gas heating, etc. So when we start to look at things like the usage, it comes in different forms, and I didn't capture a single rate, but this here is called a time of use, and this changes all the time from the various energy retailers in terms of how they report this information back out to us. But and that's kind of their complexity. They keep it complex to try and keep us, the general household, unaware and in the too hard basket from trying to figure out how they actually created the bill in the first place. So we end up getting this and we run it through to end up getting the load profile, which powers those graphs and charts. So if we look at integration into machine learning, just to take a step back for a moment, we can integrate at many different levels, and they can broadly be bucketed into down at the data level. We can integrate it at some sort of data layer, just having rows and record sets and those things moving around between data repositories, with most likely the applications living above them totally unaware that that's going on. So that's kind of sets a purpose, particularly if you're moving around large pieces of data and it becomes systems driven out of databases where a lot of the business logic is in the data itself, because it makes sense. You might have millions of records and it's too slow to move all that stuff into application space, crunch it in there, and then, you know, put results back. So generally, you know, at the data level, that's one way. Then we start to look at things like, you know, integrating at the messaging level, and, you know, products like BizTalk, Logic Apps, obviously Service Bus, you know, potentially Event Grid. All of these different technologies assist and enable us to do it at the messaging level, which is, you know, fantastic. Fault tolerant, durability, you know, all that stuff that we tend to live, eat and breathe in, you know, in the integration world. And then move up to APIs, API management, and so forth. And then, you know, potentially application to application at, you know, some very high level type things, which could be, you know, simply you've got an iframe in a web page and there's another widget from another application that lives within there as a tile or as its own single page application in itself. So, you know, there's a variety of different ways that we can tackle integration. It's not just one way. So always good to be thinking, what's the best way to connect, you know, my two worlds together? So in terms of machine learning, recently Microsoft have been focused on ML.NET, which runs on .NET Core, and basically it's a client-side library designed to give you some of that ML functionality down in that space. Very handy for IoT devices, edge devices, also cross-platform, Mac, Linux, etc. It's evolving, so, you know, certainly watch this space. It's been brought out now today with particular purpose in mind. It doesn't do everything, but obviously they've brought it out to target their initial piece of functionality that they want to expose down on the client. We've got web services, and, you know, we've also got the data layer that I've tended to identify as well. So inside our machine learning experiments, we, as they're called, when we're, you know, working with the model and running it, think of SSIS if you're familiar with that in the SQL terminology, and there's just more and complex type shapes that you can add. And so we can massage the data and do a lot to it within this experiment before the model runs it, or as part of the model, or as the output of the model. So, you know, if you're dealing with a handful of numbers, there's no problem in dealing, you know, in posting that through as a web service. But generally speaking, when you run some sort of machine learning environment, you can give it some IDs to kick it off, and then you can say, all right, well, it's going to use those IDs. It's then going to need a whole raft of data to work with and work on, and then spit out a result. So that's, you know, generally the way these things go. So from my web service, I could have a request response. So I could go away and call an environment, have it run some Brainiac type stuff, and then give me an answer back of 5 or whatever that looks like. Or I could, you know, go and execute an ML environment, some environment, and I could see some new data living in one of my database tables, for example, or in blob storage, or, you know, in a table, in an Azure table, wherever that is, right? So, and whatever form that takes. So, you know, these are just some different ways that I can work with my machine learning. And I can also have some combination of both. So I could kick off a web service, get a result back, but in the background, my data layer has also been updated. So there's some pretty cool things that we can do. And so I used a combination of both. Let's go to the tape, and you know, it's not going to be a presentation without stepping into SQL. So hopefully you guys can see that. That's big enough for you. And all right.
That looks good, Mick.
It looks good? Okay, thanks, Bill. There we go. So just to show you a few things, I'm just in UAT here at the moment, and I've just selected the you know, top top 10 bills, just to give you an idea of what a bill looks like in the system. We have this number called a national meter identifier. It's like a unique number to your meter that lives out the front of your house. And then there's things like the number of days, there's various usage numbers and so on, and a few other bits and pieces through here as well. So what I've decided to do is to use in UAT bill number 1204. Don't worry, that number is not specific or particular in any way, shape or form, just some test data. And you can see here this is a wrong. This is wrong. It should be something that's a little bit more concise, but don't worry. So I've got a bill start date, a bill end date. I've got enough days on this bill being 94. And I've then got some other details through here as well, such as some of my usage. So I've got my usage in here, some details around the total and so forth. So that's really good. So in terms of our system that we've got, one bill can have multiple periods on it. So they do some amazing things. So you could have halfway through your bill, something changes, rates change, or you've moved to a different plan. So they tend to give you one bill with multiple child items in it called bill periods that we came up with. And so you can see here the usage, which tends to be important that we want to pick out of this. So using the bills and the bill period starts to give us the information that we want. So I've now got a stored procedure that brings that concisely into what we would like, which is a start date, an end date, and then remember some of those benchmark figures that we saw on the screen earlier. So the number of people in the house, do you have a pool, your location, is there any solar there? And then, some of the other details around usage. So this effectively is what helps power the model. So I'm now going to jump out to the model and just show you a little bit around that. So I'll go into my portal, and we've got our machine learning studio and web services that are here. So I've just clicked on that already, and we end up getting this here that says, right, well, here's my machine learning in Southeast Asia. I can go to my studio where I want to go and work on my experiments and start to do my work. Once all that's been published, I can then come down and look at my web services and tweak those and find out some more details on how to work with them. So I'll come to my experiments here, and I've clicked on that. Now, just a couple of things. As a tip, it's easier with the tooling these days. If I create something in UAT and I want to move it into prod, then it's easier to do that if they're in the same region. Okay, previously I had them in other regions, and then it was a nightmare to try and copy an experiment over. I had to run a whole bunch of PowerShell scripts and so forth to do it. Maybe in time that will be fixed, but certainly, the easy way to solve this is to say, well, in this region, here's your UAT, work away. Once that seems to be fine, then you can quite easily copy and move it over into prod. And prod is a totally separate environment to UAT. So if you copy things over, you've also got to copy over all the artifacts and potentially reconnect them if they're new and things like that. So don't worry, there's no crossover, overlap, or pollution in there. So this UI and this layout has been around for quite some time, and I'll show you what electricity looks like. So I've got electricity, we've got gas that this runs for, and let me just bring that down a touch. Oh, that'll be all right. So there's a few things. If we work from the left-hand side, over, going, right, we've got a shape that's an import data shape. And basically it connects off to an Azure, to a database, a SQL database, and says, go and get me some data. And what that runs is essentially this stored procedure here to returns this back in JSON. So goes and gets that. Now, depending on how many bills you load, and in this case, this data is pretty simple, but the more bills you load, then the more data goes into the model. And so that, even though we've got one row, in other households, for example, there may be 100 rows. Now, there's another part up here that says enter data manually. Now, there's also there's also a library of here of basically the modeling function. So here's machine learning, and this is just the part I wanted to just pause on for a moment. So there's a series of different models down this left-hand side, and this gets richer and richer all the time, all these options. Fantastic. It's great to see, and you can come along and say, hey, I'm going to go and use R. Recently, not too long ago, they decided to support Python. Now, in our case, we had a Python, call them a data scientist, but we had someone who was more familiar with Python than this environment here of the various models and things like that. So just to show you the flexibility, they modeled something up locally on their Mac, it was, in Python, and said, this is exactly what we want to run in production, going through the steps, but this is exactly what we want to run. So to the benefit of machine learning, we were able to just pick that library up and upload it into this environment and then use it from within the execute Python script shape. So it gives you some very interesting options if you want to go down this path. And if I showed you the execute Python script, here you are. Oh, come back. There we go. And I'm just going to open that up. Basically, I wrote some script here that lived under this routine, and it's all about passing in data frames in Python. Call it a data set or a record set for Microsoft speak. And basically there was a bunch of data. We go through the rows in that data, go and run calculations on each individual row, and then accumulate all the results back together, take all the outputs of those results, and then run a final prediction across them inside the Python, and then return the results back out as JSON. So it really, I don't want to sort of get bogged down into exactly what that is and what it isn't, but what we need to write is, if you like, the interface or the wrapping code that allows us to go and run these functions given the data that we need to go and run it. And that's that's that guy. So I'll just see if I can bring that up again. Because one of the other things that I can do is to say, well, show me the output log. So this is an output log of the Python that's been executed by machine learning, and it's actually setting up the environment. It then starts to take the various arguments in to go and run the results, and I can output some of the things that I might be talking to through here. So these are these data sets or record sets, and just to give you a bit of an idea, remember that row that we saw from within the database, or rows, that's it here represented as Python, which is beautiful, because now we're ready to roll and we can start to run whatever it needs to run, and then some other parameters and details down through here. So it's quite verbose in this situation, because what you don't want is, you have this data, you run some models, code, whatever it might be, you run some Python, you get a result coming out here, and you go, well, I should be getting 5 out, but I'm getting the number 7. where did it go wrong? You know, really handy to help. So just to, so let me, that's okay. All right, so as you probably guessed, the main thing here is that this execute Python shape, because of our local knowledge that we had with Python. And it was easier for us to get that up and running, get that modeled in Python than it was to go away and use, you know, some of these shapes. Similar sort of story if I'd used R, for example. You know, go and create a model and work with it and so forth. Now, the beauty of this is that I can take that Python untouched and run it here. Previously, we were looking at different ways on how to take that Python. Do we convert it to .NET? Do we wrap it, make it a, you know, a web API type framework around it? I could just see it causing so much trouble, because if a problem occurs and the incorrect result comes out, is it the Python? Is it the way that we translated it? Is it the web APIs? Is it, you know, .NET platform? There's just a whole other bunch of things that come into the scenario. So I'm just going to move on a little bit. A couple of interesting things. You'll notice there's a web service output shape, but there's not a web service input. Now, if I look at, and just to show you these guys, right? If I look at this input data, I've actually come along and said, make this a web service parameter. And I'm just, you know, yeah. So I've clicked on this and said, this box, this thing called a database query, make that a web service parameter, because what I need to do every time we run it against a different household, we need to execute that store procedure effectively for that household, for the bills that they have, for the usage data they have, not this one that's been stuck in here for training purpose, or just for, you know, my work and being able to just run it here within this workshop environment. And then the other side here is I've actually got enter the data in manually here as well. So I've made that a web service parameter as well, so that becomes important when we output the data, so I can link the results to that bill and we can then process it further. So the way that this works is that we take the data coming in, we have our Python, it executes, there's an output that goes to a web service output, and there's also an output that lands in a table called TBL ML predictions inside a database. So the output of this model is inside a database. The next step is to take that output and push it through the system. It goes to about 15 different places, push it through the system and recalculate various numbers, of which one of them is to drive those graphs that you see on that initial screen. So let me just take a step back. So once I'm happy with all that, I can come along and say deploy to a web service. Okay. So I can, we can play in this environment, we can work it, we can get rid of the X's, we can get some of the right results. So I output it here into a table. I can go into SQL, for example. I can say, well, what do some of these results look like? And so the results that these have been from previous tests and training and so forth, but these results is a chunk of JSON, and that's what should go off and be processed further inside the database in this particular instance. And that's what does happen. And that's what does happen. So I've then gone away and published my web services. So there we are in the web service management. Clicked on that, I can see my web services, and I'll go into my electricity web service. So this is one of the newer interfaces that are around my web services. So I can look at manage and monitor. The part that, and I can also get Swagger and Swagger definitions of this, which is fantastic. I can also test my web service, and I can look at, I click on the consume. I'm just going to skip the bits up the top. There's some keys and various bits and pieces. But the part that I quite like is it comes down and says through here, this is how you're going to call it. And it also defines those global parameters that I need, and also, you know, the data itself. And then here's some of the keys. So just taking a step forward again, here's some code where we get seasonal, I'll get seasonal usage by NMI, by the right one that we want. And yeah, that's right. Right. I've actually got, yes, that's right. So this is my API. No, it's not the right one. Let me grab you that. Okay. In the interest of time, it is seasonal usage by NMI. This is the guy. Do I have anything that's... How about that? Okay. I don't have that one here just now. Right, I'll come back to that in a tick. But basically, it was purely this implementation in here. And, you know, look, there's so many different ways you can extend it. You can add to it. This changes all the time. We can make it async, etc. One of the things that we don't want to do is keep all these magic numbers inside code. So put those elsewhere. All of these things, because it just makes it easier to have the same bit of code calling, how I had prod and UAT web services. It just makes it easy to have the same bit of code doing that without hard coding some of those numbers in. So if I'm to go away now and run this and test it, which I will do for 1204, so I'm now, that's the one I want. So I'm now going to get, sorry, I took a step ahead. So I'm now going to call that particular operation, and it's gone away, executed the model, coming back. Now, in our case, we don't actually use a request response, but here is that data just in case on our system we wanted to. And it was potentially asleep there for a little bit, and I'll just run it again from here, and generally it's very, very quick. It's sub-second stuff, and I'll just show you now. There we go. So this is exactly the same bit of code, and you can start to see that here's my new client. I'm going to go off and call it. I get my config, my key, and my URL from an external config floating around. We set up the global parameters to say, hey, you're going to go and execute this particular store procedure, and that's a parameter that I want you to go and run, which is the bill ID that we are passing in to this particular operation. Grab the results and display them to the screen. So, effectively, this is the line here that we use to integrate in with ML. Now, no one else really knows that. What I wanted to do, and the reason why I wrapped it, if you like, and put it into, a classic sort of API here, is because the URLs and these sorts of things were quite long and ugly, and they also had various, regions associated with them that quite frankly, I didn't want I didn't want to have to contend with. Whereas here, this can be deployed, this API can be deployed multi-region, standard naming convention, etc., and then we can make it do whatever we want internally, which is, you know, classic sort of wrapping style of all of this. And finally, just to wrap up, if I now turn around and say, well, just show me that usage data. So here's here's a call that we would use to make those graphs and so forth in the app, and that's the NMI, which is Atom 10, and then this is some of the data that is used to drive those graphs. So, you know, things like maximum usage, so I can get the scale of the graph and what we used in summer, what we used in spring, etc., and so on. So, look, it was it's pretty good. It's always evolving, always learning, and you know, for us, it's a very easy sort of style to go ahead and work with, purely because we've got some in-house Python expertise. When they change the model, it's simply uploading a new zip file, and in ML world, it's kind of a way to productionize it and make it available for the enterprises, which what, you know, Microsoft does a very good job at. So I can call that environment, you know, many times a second and get some amazing results out of it, which is, you know, which is something that makes me sleep easy at night. So I hope you enjoyed it, and you know, shared a little bit around, you know, what was going on, and I'm happy to, you know, take some questions.
Thanks, Mick. Does anyone have any questions? The question window's open out there. Okay. Just to give people that might be running BizTalk still an update, it looks like we've discovered a gotcha with some security patches that ran this weekend, or ran last night. There's a cumulative, the 2018-07 cumulative update for Windows 2016, and it looks like 2012 R2. KB, one of them is KB 4338814. It breaks BizTalk. So I'm doing some more research with a couple other people at the moment. Yes.
Yeah, put that on Twitter when you can, so that we can circulate that to everyone else.
Yeah, because what I did is I tried to move some of my stuff tonight to a 2016 environment, and I just patched that 2016 environment today. And when I tried to deploy to BizTalk, it failed with the same error that Mark was getting. So yeah, if you watch my Twitter and watch I'll cross post it to Integration Down Under too. And it looks like if people are running the security patches, we're going to have issues with BizTalk. But thanks everybody for attending the Integration Down Under session. If we don't have any questions, let me just check the question window. Oh, there is one question. Hold on. Mick, can we somehow skip the Python to the R Python to train the model?
Yeah, sure. You know, you could do what we did in a model natively in Azure, in ML for sure. Just that our expertise lay in that realm. So rather than go through a classic sort of model, we said, well, is it possible to incorporate this exact scenario? We said, well, we've got the answer in Python. How can we run it in our system?
Yeah. So yeah, I mean, it's also one of the features. Microsoft's doing a lot more stuff open source, so you've got Python support there, and so a lot of different ways to do it, because they're pulling people from all different areas into Azure now with some of this other support. So, how do you verify the results?
Yeah, look, we do have some tests that we run. So basically, the tests are around supplying a year's worth of data and then seeing what the usage results are. And yeah, so we can go off those. Essentially, the more data that you give us, the more bills that you give us, then the more accurate the result is.
Okay. Any other questions? Okay. This recording will be available up on our Facebook page, or not Facebook, YouTube, for the Integration Down Under, and we'll tweet it out on the Integration Down Under Twitter account at the same time. So thank you very much for everybody that's attending, and I'm going to end the webcast now. Thank you very much.
Thanks,
Thank you,
Thanks, Bill. Thanks, guys.